Good evening, everybody. So, this is the third problem that we looked at today. It is a stoplight turns green and Mr. Machewski puts the pedal to the metal. His car can reach a maximum acceleration of 2.0 meters per second. How long does it take to travel the 300 meters to the next stoplight? And if the light is going to change in 15 seconds, does he make it through? So, as always, we start by setting up our variables and listing our equations. So, S equals xi plus vit plus 1/2 at squared. And a equals vf minus vi over t. Then we're going to list our variables over here. It's going to be an s, xi, vi, vf, a, and t. And then we're just going to look at our problem to see which variables we already have. So, a stoplight turns green, and then Mr. Machewski puts the pedal to the metal. Well, that means that we start from a stop state. We start from rest, which means stop. That's our key word. Our velocity at that point is going to be 0. And since that's the start of our motion, then our initial velocity is 0. We know that our acceleration is 2.0 meters per second squared because we're told an acceleration, and we have the units, meters per second squared. So 2.0 meters per second squared. How long does it take to travel the 300 meters? Okay, so 300 meters. There's two places that this could go. It could either go in our xi or our s. Now, you could technically set this problem up so that your starting point is 300 meters and you're counting down to 0. But then everything would be flipped negative. So we're going to start from 0, and we're going to go to 300 meters. Okay, so we're missing VF, but we're asking how long does it take to travel? How long? We're looking for time. If it was asking us how far, it would be looking for distance. Or if it was asking for what is the final speed, or what is the speed, how fast, that would be a velocity. So we actually don't need our final velocity to do this one. So let's take a look. We're solving for time. And we have an S, we have an XI, and a VI, and an A. So we're going to go ahead and use this one. We don't have a VF, we don't have a T, so this would be of no use to us. So I'm looking at this, and I'm just giving a cursory glance to see if there's any simplifying I can do right off the bat before I plug my numbers into this. And as a matter of fact, I'll write it over here just so we have a little bit of space to change things. So I know xi is 0, and I know that anything plus 0 is going to be the other thing. So I can actually just drop it from my equation. I know that vi is 0, and I know that 0 times anything else is 0. So vi and t together would be 0. So I know that this will drop as well. So I'm left with s is equal to 1/2 at squared. So I'm going to go ahead and rewrite it and plug my numbers in at that time. So 300 for s equal to 1/2 a, which is 2, t squared. Now, what's 2 times 1 over 2? Well, that's going to be 1. So I'm left with 1 t squared. Well, anything times 1 is itself, so I'm actually left with 300 equal to t squared. Does everyone see how that worked? I had a 1/2 times 2, so that would be 2 divided by 2. That would just be 1. So 300 equals t squared. So how do I get t then? Well, I have to square root. That is the opposite of a square. So square root both sides. And if I square root 300, I end up with 17.32. That's going to be in seconds. It's equal to t. There we go. So we're going to write that in on our variable list so that my instructor can see what my answer is clearly. Doesn't have to take any points. Doesn't have to mark anything wrong. Which makes him happy because he feels like a good teacher. So 17.32 seconds. And that answers my second question. He, in fact, ends up having to stop at the next light as well. Welcome to my morning commute. Thanks, everybody.